My name is Kikela Mosilu. I teach physics as a subject. Today, I'll be talking about expansivity of solid, liquid, and gas, its effect and application. During the course of the lesson and as the lesson progresses, the students will be able to define expansion, describe expansion in solid, liquid, and gas with examples, and explain the effect and application of expansion. Expansion is the increase in size of an object when it is applied. Contraction is the decrease in size of an object when it is removed. Expansion in solid can be described using the ball and ring experiments. When it is added to a solid, it increases in size, which is known as expansion. Now from the video, we see that the ball, which is a brass alloy, can pass through the ring because it has not been added to it. It has not expanded. You can see it passing through the ring. And when we apply it to the ball, it expands, making it difficult for it to pass through the ring. Can we see it? That's that, using the ball and ring experiment. Expansion in solid can further be explained using the bimetallic strip. Bimetallic strip is the joining together of two metals of the same material or of different materials. Initially, when it is not applied to it, according to the video, we see that it is a straight bimetallic strip. But when it is applied to it, we see that the strip begins to bend into a curve, showing that it has what? Expanded. On heating, the bimetallic strip, which is made of two different metals, expands and bends into a curve. Steam pipes. Pipes carrying steams from boilers are fitted with loops or expansion joints to allow pipes to expand and contract easily when steam passes through and when it cools down. Telephone wires. Telephone wires are no more in vogue because most of us now use wireless phone. But we can use other examples as the power line and the other different wires that brings in electricity into the main building. During cold weather, they contract, and when it is warm, they expand, making it look saggy. When we see it in the afternoon, it appears longer and slackened, but in the morning it is shorter and stout. Steel bridges also are made of steel girders. While one end is fixed, the other end is placed on rollers to allow for expansion as shown in the diagram. Expansion in liquid. When water is heated, we can see that we have a conical flask or a container that is attached to a retort stand, and the volume of the colored liquid in the container is read as V1. And what happens? As heat is applied to it, we see that the container expands and the volume of the water initially decreases and begins to rise. You can see when it is applied to it, the container expands first and the level drops to V2. And as the increase in temperature rises, the volume also increases. Expansion and contraction in gas. This can also be experimented using a conical flask with some water in it or some liquid in it. Place it on a heater, and what do we see? Once the conical flask is placed on heater and it is covered with a deflated balloon, as the temperature of the water begins to rise, we see that the deflated balloon begins to increase. the deflated balloon begins to increase. Yeah, that's the diagram, it's just coming up. You can see the increase in the deflated balloon to show that the temperature is increased, and as it increases, since the gas cannot escape, the only way of escape is where the balloon is covering. So the gas is the one filling in the balloon to show that what there is increase. You can even see the water boiling. The water begins to boil and the temperature increases, thereby making the balloon grow bigger and bigger and bigger. This is expansion in gas. Now for us to see the contraction, we are going to, from the video, the flask is lifted and placed into a cold bowl of water. And what do we see? We see the balloon reducing in size to show us that what temperature is what decreasing. You can see the size of the balloon going down. The effect and application of expansion. We have rail tracks, explosion of a fuel tank, riveting, water bursting in pipes, in cold weather, mercury expands. There are so many examples to show that these are the effects of expansion. Let's start with the explosion of a fuel tank. The fuel tank was filled to the brim, and due to lack of space in the tank, it opens up the cover and spilled out when the temperature from the sun is much, which results to expansion. Another example is the rail tracks. Because there are no spaces in the rail tracks, it will expand and make, like we see, when it is added to the metal, it expands, and when it is cold, it contracts. So if there is no space for contraction and expansion, what happens? The rail will expand and derail the train, or contract and derail the train. But when there is a loop or a gap between the rail tracks, what happens? It allows for expansion and contraction. Thank you. Please like, share and subscribe. Goodbye.